Hello, welcome back to Excel in Life. Today, I'm excited to show you how to create a bar bending schedule using the BBS Plus Platinum. It's a great tool for preparation of BBS, optimizing your rebar usage and also reducing wastage. I've got something extra special for you. The BBS Plus Platinum version 24. Yes, you heard that right. With this video, I will showcase the new feature introduced in BBS Plus Platinum version 24. If you're new here, don't forget to hit that subscribe button and the notification bell, so you don't miss out on any of our upcoming videos. So let's get started. Today you'll see how to make bar bending schedule of footing and column. For that, I have taken a sample drawing of footing and column. To make the BBS, I will be using BBS Plus Platinum version 24. This is the latest version. In this version, apart from making of bar bending schedule and tag generation, a new feature is introduced in optimization. Till date off-cut rebar generated in optimization sheet was not used, but now an off-cut sheet is included, which will save all the off-cut from optimization sheet. While doing optimization, now software will first look at off-cut data. If any usable bar is available, then it will take from there. After that, only it will search in full-length bar. This will ensure off-cut bars are used most, and your project will have no wastage of rebar. You cannot delete this off-cut sheet. If you try to delete the sheet, it will give you this error message. At initial stage, if there is no off-cut, you can delete this data. You can also enter the actual off-cut stock before optimization. Let us insert a new sheet to start BBS. Software will ask you to select BBS format or balance sheet. Click Insert BBS format. I have written the company name as Z's Limited. You can customize company name, project name, structure. You can update this in template sheet. Whatever data you will write will be available in all new sheets. You can even change the logo from here. When you save, a new sheet as per template data will be inserted. Let us delete the extra sheet. Always remember to give bar markings sequence and unique. This will help you to identify the bar from tag by the bar mark. In this case, sheet 1 having serial up to 4, sheet 2 up to 37, sheet 3 up to 71. Hence, I will start sheet 4 with 72. Let us check the drawing. We are having for numbers F1 and 2 numbers F to footing. Size of F1 is 1300 by 2400. We are considering 50 millimeters cover. Bottom bar shape is straight line. There is no L at end. To calculate the number of bar, we have to remember L side is 1300 and B side is 2400. Rebar is 12 tor 100 center to center. Let us write bottom bar towards L side. Die of bar is 12 millimeters. Number of elements will be number of footing. We have for numbers F1, so we will write 4. To calculate number of bar, we will take the length of B. That is 2400. Then deduct to times cover, then divide by rebar spacing 100. Then add 1. Apply round formula to avoid any fraction in number. Next we have to write code number. Click common shape to get the commonly used shape code. Code of straight rod is 100. Length of the bar will be length of side L. 1300 minus to times cover. Now bottom B. Dia of bar 12 millimeters. Number of element is 4. To calculate number of bar this time, we have to consider length L. Copy the above formula and change the length to 1300. Shape code 100. Length 2400 minus to times cover. Next we will write BBS for column. Our column size is 550 by 550, and we will consider column height up to DF, that is 2400. Column rebar is 8 numbers 20 mm dia bar. Bar mark 74. Column vertical. Dia 20. Number of element 4. Number of bar 8. Now find the shape code of L-shaped bar, which is 111. Dimension is given in drawing as 375. As we decided to keep column rebar up to dimension DF. Dimension B will be value of DF. That is 2000 for 100 minus cover 50 and BFS 75. Now a time for stirrups or column ties. In our column, 2 types of stirrups is available. Square and diamond. 10 mm bar dia 100 center to center. Let us consider column cover as 40 mm. For identification, we can write footing number and description. Let us enter detail of ties. Dia of bar 10 mm. Number of element 4. To get length where ties will be placed, we have to consider value of DF 2000 for 100 minus BFS 75 minus footing depth 300 minus 65 clear and then minus GB 600. To get the quantity, divided with spacing 100 and add 1. Apply round to avoid fraction in number. Next we have to write code number. Shape code for column ties with 135-degree hook is 501. Enter shape code 501. Our software calculates stirrups cut length based on outer dimension. Value of A will be column dimension 550 minus to times cover 40. Value of dimension B will be same as dimension A. Next we will write diamond stirrups. Bar mark 76, F1 column ties 2, 10 mm bar, number of element 4. Number of bar 15 as above. Now we have to find diamond shaped stirrups. In common shape floating window, this shape is not available. Then how to find the shape code? In BBS Plus tab, click Find Shape Codes. You can filter with number of angle and curve. For easy solution, click Show All. This will show all working shapes. From here we are seeing that code of diamond stirrup is 588. Formula to get dimension A would be square root of summation of half of each side square. Apply round formula to avoid fraction. Since this stirrups is square shape, we can apply the easy formula. Square root of 2 multiplied by half of each side. Hook length is coming through formula. Dimension D is for reference only. We have completed the footing and column BBS. Now we will see how to do optimization of cut length and also generate tag. If you want to know more on BBS Plus, you can read this article. I will share the link in the description. In this article, I have explained how to install BBS Plus, make BBS, and also generate tag. You can purchase BBS Plus from excelinlife365.com. It's time to optimize cut length. Before that, we will do consolidation. We will consolidate other 3 sheets we have done earlier. We have listed some off-cut rebar in this sheet. This will be used during optimization. To start, click Option, then click Consolidate. Selected sheet name will be visible. Pour number will be generated automatically. Click Enter to include in list. If next sheet comes automatically, then click Enter to include. If you want to include some sheet, then select that sheet. After that, click Pour Number. Your sheet will be displayed. Then click Enter. This way you can include all sheets as long as memory supports. Click Clear to remove any sheet from the list. Now click Consolidate button. it will consolidate all the selected sheet in a new sheet. New sheet named based on date and time. Next, click Sort. There are two sorting options available. One, shape code-wise sort, which is convenient for bending. Two, cutting lengthwise sort. This will reduce wastage of steel. You can keep no numeric bar mark separate during sort. In our case, it is not required, as we have given all numeric bar mark. Click to sort. Sorted bar of BBS sheet will speed up the process of cutting, bending, and reduces wastage by use of off-cut bar effectively. Sorting never changed the original BBS sheet. A new sheet will be created for sorting. Once sorting is completed, click Optimize. This will open Optimize option. Here, dia-wise stock length can be entered. Tick the summary of wastage. By default, 30 times diameter is set as scrap, but you can change to any figure from 10 to 500. This will optimize cut lengths as per selected option. Remember, you can optimize and generate tag multiple times, selecting the sorted sheet. Once optimization is done, click Create Tag. Production sequence numbers comes automatically. You can enter other details like order reference, project, schedule reference. Unload location, pour number comes all automatically. You can change any data like we are changing member detail. You can make multiple tag if weight is to 100 kilograms or more. Click Create Tag. As we selected Group ID, sheet-wise ABCD is marked on tag. In this tag, you can see our column vertical with bar mark, shapes, weight, numbers, etc. Similarly, all tags are taken from the BBS we prepared. In this optimized sheet, off-cut bars are properly used. Wherever off-cut bars are used, it is separately highlighted. This will prove how BBS Plus Platinum is saving your cost. Summary section displays dia-wise stock weight, finish weight, scrap weight, off-cut weight, and also percent of scrap and percent of off-cut. In this example, we are getting 0.6% scrap. This will vary based on the BBS. Off-cut is updated with the off-cut data from the optimized sheet. It is observed that in a project of 2,000 to 2,500 ton rebar work, you can save $40,000 to $50,000. After consolidation, a text box is inserted in sheet to avoid further use. To reuse this sheet, you have to delete this text box first. In summary, we've learned about BBS Plus Platinum, a helpful tool for making bar bending schedules. It helps builders save time and cost and work smarter on construction projects. Thanks for watching. I hope you liked learning about BBS Plus Platinum. If you have questions or want to know more, just write in the comment section. BBS Plus Platinum does lots of cool things, like figuring out how long bars need to be and how many are needed. This is helpful for procurement of rebar. Remember to click like and share, and subscribe if you want to see more videos like this. See you next time.